welcome to Virtual Pathfinder channel. Today we're going to have a look at the planet Uranus and how to image it using a telephoto lens on a system camera. First of all, let's have a look at the planet itself. This information about Uranus is from NASA's website, and as you can see in the images, there are few features on the surface. That is to be expected since it is a gas giant which only has some visible bands on the surface with various nuances of blue. When looking at the image shot by the Hubble Space Telescope, it is possible to see rings around the planet. Uranus was the first planet found with the aid of a telescope. It was discovered in 1781 by the astronomer William Herschel. Originally, he thought it was a comet or a star. It is the seventh planet from the Sun. It has an orbital period of 84 years and it rotates east to west. Uranus' rotation axis is tilted almost parallel to its orbital plane, so it appears almost to be rolling along on the orbital plane. The reason for this may be a collision with a planet-sized body early in the planet's history. Because of Uranus' unusual orientation, the planet has extreme variation in sunlight, especially in the polar regions, which have almost 42-year-long period of continuous sunlight, followed by an equally long period of continuous darkness. The planet is about 20 times further away from the Sun compared to Earth. It takes 2 hours and 47 minutes for the light from Uranus to reach Earth. It takes almost 10 years for a spacecraft to make a one-way trip to Uranus. The radius is 4 times that of Earth, and the rotation period is about 17 hours. Voyager 2 is the only spacecraft to visit Uranus. It imaged Uranus in 1986. Although that was a close-up image, it reveals almost no details in the visible spectrum. Uranus reached equinox in December 2007, when it was fully illuminated as the Sun passed over the planet's equator. By 2028, the North Pole will point directly at the Sun, a reversal of the situation when Voyager flew by. Voyager 2 is a fantastic piece of engineering. It has been traveling since 1977 and is now in interstellar space, still communicating with Earth to the NASA Deep Space Network. Although the signals are getting fainter, it is expected to be operational until about year 2030. If Voyager 2 continues undisturbed, it will reach the star Sirius in about 300,000 years. That puts things into perspective. Uranus has clouds, including rapidly evolving bright features and a great dark spot like those seen on Neptune. Uranus is one of the 2 ice giants in the outer solar system. The other one is Neptune. The atmosphere is mostly hydrogen and helium, with a small amount of methane and traces of water and ammonia. Uranus gets its blue-green color from the methane gas in the atmosphere. Methane gas absorbs red portion of the light, resulting in a blue-green color. 80% or more of the mass of Uranus is contained in an extended liquid core, consisting mostly of icy materials, water, methane and ammonia. The temperature is estimated to be around minus 216 degrees Celsius. The density is estimated to be 1.32 grams per cubic centimeter, which is low compared to Earth's density of about 5.51 grams per cubic centimeter. As a side note, I can mention that water has a density of about 1 gram per cubic centimeter, which is higher than the density of the gas giant Saturn. That means if it was possible to put Saturn in a bathtub on Earth, it would actually float. Just as Saturn, Uranus has rings. Actually, it has 2 sets of rings. The inner system of 9 rings was discovered in 1977, and it consists mostly of narrow dark rings. Voyager 2 found 2 additional inner rings. An outer system of 2 more distant rings were discovered in Hubble Space Telescope images in 2003. In 2006, Hubble and Keck observations showed that the outer rings are brightly colored. The magnetic fields are typically aligned with the planet's rotation. Uranus' magnetic field is tipped over. The magnetic axis is tilted nearly 60 degrees from the planet's axis of rotation, and it is also offset from the center of the planet by 1/3 of the planet's radius. The magnetic field of both Uranus and Neptune are very irregular. Uranus has 27 known moons, named from characters from the works of William Shakespeare and Alexander Pope. The 5 major moons are Miranda, Ariel, Umbriel, Titania, and Oberon. The equipment I used for imaging Uranus is a mirrorless Micro Four Thirds camera, Olympus OMD EM5 Mark II, with a Samyang 85mm f1.4 lens. The camera was set to the high resolution mode to give a 64 megapixel image at ISO 1600 with a shutter speed of 1 second. The aperture was set to f2.0. The camera was attached to a Vixen Polari star tracker on a tripod. Considering the short focal length and the fast shutter speed, it may seem unnecessary to use a star tracker, but it is a high-resolution image, and when cropping to get higher magnification, it is necessary to track even at short exposures such as 1 second. The reason I did short exposure is the limitations when using high-resolution mode, which is a maximum of 1 second of exposures, and the maximum ISO setting is 1600. To locate Uranus in the sky, I use the iOS app Sky Safari Pro, which makes it possible to find the planet in the sky at each point in time. It is possible to display the image circle representing the field of view of the camera lens, which is about 14 degrees. The image circle will show the area the camera will be capturing when directed towards the sky. Finally, here is the resulting high-resolution image of Uranus. I will show a side-by-side image of the photo and the display from Sky Safari Pro confirming the location of the planet. That was all for this time. If you want to see more content like this, remember to subscribe to this channel. Virtual Pathfinder is also available on all the major platforms. If you want to see more material and support the channel, consider joining Virtual Pathfinder on Patreon. See you in the next video. Have a nice day and many starry nights.